Let us take a look at this question here. Find a modulus and arguments of each of the complex numbers in exercise 1, 2, 2. In these two, we are supposed to find the modulus and arguments of the complex numbers. Now, how do we find the modulus and argument? Let's take a look at that first. If we have any complex number z, if we have any complex number z, let us say x plus I y. If we have any complex number z, is equal to x plus I y. The modulus of z is represented by this symbol mod z. It is read as mod z, and the value is simply equal to under root of x square plus y square. What does modulus of z signify, by the way? Modulus of z signifies when we draw the argand plane, the modulus of z, any point for any point z, which is x comma x plus I y, the coordinates of this point will be along the real axis. We have to move a distance x, and along the imaginary axis will move a distance y. This is the real axis and this is the imaginary axis. This is the origin over here. So modulus of z basically signifies this distance from the origin to this point P. Modulus of z represents this distance. This is mod of z. As you can clearly observe, this is a 90-degree angle, and x square plus y square under root will give me the length of this hypotenuse over here, which is what we obtain. What else? We are also supposed to find the argument of z. So argument of z is generally denoted by the angle theta, where theta lies in a particular interval. Theta is greater than minus pi less than equal to pi. This is as per notation we consider this angle, right? Theta could have been anything from here to here. Let us say theta could have been from 0 to 2 pi as well, but then 0 to 2 pi is not something which we consider. We consider from, let us say this is 0, so we start from here minus pi to pi. This is the interval that we consider for theta. These are the principal values of argument of z. Principal values of argument of z lie in this interval, okay? And the angle made by OP, with positive x-axis, that is my theta. That is my argument of z in general. So when the point lies in the first quadrant, it is very simple to find the argument of z. When the point does not lie in the first quadrant, we have to apply some common sense. Yes. Let's say the point lies in this quadrant over here. So the location of the point is important. Yes, the location of the point is important. If theta lies in this direction, then OP would be actually this, let's say, okay. In this case, theta would be this, okay. This is the argument of z. How do we find theta? First, we'll easily find this alpha. And how do we find this alpha? This alpha can be easily found with the help of this right angle triangle over here. Tan alpha would be equal to this perpendicular upon this base. Take the positive values only, and this is perpendicular upon base. You will be able to find alpha very easily. On the basis of that, you will be able to get the value of alpha, and therefore you can find theta. Theta would be simply equal to pi minus alpha. Can you observe that? Yes. Theta would be equal to pi minus alpha, as you can clearly observe over here. In case we have point P lying in this quadrant, so what we'll have is, similarly we'll find alpha in this case. As well. How do we find alpha? This angle would be alpha in that case. With the help of this value and this value, perpendicular and base, we'll find alpha. And the value of theta would be this case. The value of theta, this theta would be actually equal to minus pi plus alpha. The value of this theta would be actually equal to minus pi. This line is minus pi, or this line is pi as well, right? Minus pi, then again you can come over here and say this is 3 pi. But for us it is, like, say you begin from here, you go to here. This is an angle of 180 degree or an angle of pi. You have covered an angle of pi from 0 in the positive direction, therefore you reach pi. In the negative direction, you will reach minus pi, right? So in this case, in this particular quadrant, the value of theta can be written as minus pi plus alpha. For this quadrant over here, the value of alpha, if this is alpha, then you can get theta as well. This is theta. Theta will be equal to actually minus alpha simply in this case. Okay. So in all of these cases, alpha belongs to 0 comma pi by 2. First of all, let us be clear about that. Alpha belongs to 0 comma pi by 2. First we find alpha, and on the basis of that we take a call on the values of argument of z, that is theta, very easily. Alright. So keeping this in mind, let's try to find the argument and modulus for this particular complex number z. Let's try to find this particular complex number, this z. So we begin with z equal to -1 minus I root 3. Okay. Therefore, mod z would be equal to under root of the first term, that is -1 square plus minus root 3 square under root. What is this giving me? This will give me under root of 1 plus 3, which is under root of 4, which is equal to 2, simply 2. That's the modulus of z for us in this question. What about the argument of z? Now for argument of z, we know that we have to draw the diagram first and mark the location of this particular point. Let's try to do that. For finding the argument of z, let's try to draw this. There's a point, this point is -1 comma minus root 3. Can you observe? -1 comma minus root 3 would be somewhere here, right? This is what we have. This is -1. This is minus root 3. Or you can mark the point in this manner over here. This point is, point P is -1 comma minus root 3. Let's mark this point. And we are supposed to find the argument of z, which is this angle over here, theta. We are supposed to find this theta. But for finding this theta, first we'll find this alpha over here. Let's try to find this alpha. What is this length? This length is 1 unit and this length is root 3 unit. And what I do is, in the rough, what I do is I can find tan alpha very easily. Tan alpha, as you can clearly observe, would be in this right angle triangle over here, perpendicular upon the base, which is root 3 over 1. This is equal to root 3, implying that alpha is simply equal to what? Alpha is simply equal to pi by 3. Now since alpha is pi by 3, therefore theta becomes equal to what? Theta is simply, this is minus pi as well, minus pi plus alpha, which becomes equal to minus pi plus pi by 3, and that gives me minus 2 pi by 3. And yes, this is the argument of this complex number. So we have found the modulus and we have found the argument. Therefore, we can simply say z comma theta, mod z comma theta actually equals, mod z is 2 and theta is minus 2 pi by 3. And yes, this is my final answer for this question over here.